Hi. My audio might be a little bit weird just because I'm recording outside, but hope you can bear with me. So, I am doing a voiceover because my audio did not record the first 15 minutes of this. So, once again, just bear with me. But this is going to be a tutorial for how to make these 3D printed chassis jigs that you can see here. Um, as soon as you get into the assembly, you're going to want to make sure that your sketches are turned on. You can see that in this eye icon up at the top here. I think SolidWorks just naturally turns them off, but next you're going to want to insert a new part into this component. So just follow along and make sure that you're pressing all the right buttons. We're going to work on this naming convention. So you want to name it P whatever tubes, whatever tube. So you should be connecting two tubes. As you can see, some of the examples I did, P, I think 10 and 12. This one, I believe I'm connecting tubes 12 and 33. If you look at this lovely balloon drawing that Pasha created for us, you can see that these tubes are going to be, they're just all numbered accordingly. So make sure that your jigs are named the lower tube number than the higher tube number. So P012 and then 033. All right, so once you have this part actually in the assembly, you're gonna have that weird little green check mark that's just trying to place your part wherever in the assembly. Since your part doesn't really exist right now, it doesn't really matter where you click, just click anywhere. And then you can go into the feature tree and actually start editing the part within the assembly. So everything else should gray out. If not, it's fine. I think it depends on the settings of your SolidWorks. In this case, the rest of the assembly did gray out. So we're going to want to start a 3D sketch. We're going to be creating the axes of the tubes. We're going to want to make sure to have the two different tube axes as separate 3D sketches. So right here you can see I'm making one of the tubes. As you make this line, you're going to want to make sure that everything you click is orange. That means you've properly selected it and it's properly referencing the original sketch. So yeah, just using the 3D sketch, you're going to use this global variable. Now, what a global variable is it's just a variable defined within the assembly that allows you to sort of adjust the dimensions retroactively. So I have right here the length global variable that I've defined. If you just type in the text that you see on screen, that should get you the global variable. And then I was working in millimeters by accident. You should make sure that you're working in inches. So as you can see, it looks about 2 inches. That looks good. And then just roughly moving the position of the jig where you need it to be. A good rule of thumb on where you position these jigs is going to be close enough to the node where it's properly securing it, but far away enough that it doesn't affect the welds. Or, sorry, it doesn't melt due to the welds. So this right here is a little bit close, but you sort of have nowhere else to put it. But yeah, what I'm doing here is I'm making a separate 3D sketch for the other tube axis, the other tube that we're connecting to. Once again, 3D sketch, making sure that everything is orange before you click the buttons. That way you know you're properly selecting it. And then using the same global variable as before. When I use the other global variables for different things, there's more global variables than just the length. You're going to still use the same format, but as you'll see on screen, I just input, instead of length, I input something else. So here I'm positioning the other axis to be roughly vertical to the other axis. Depending on where your angles are, it might be a little bit weird, but it should be just roughly in a straight line. So now what we're going to do is use what's called a swept boss base. This is going to create the actual 3D geometry of what we're doing. So instead of the default feature as a sketch profile, we want to instead select circular profile. Now we're going to utilize another global variable. So we're going to select the first tube axis. Once again, we have to do everything in separate components. It's a little bit annoying, but um, it'll work out. So the next global variable that we're going to use is OD, just stands for outer diameter. That's going to be the outer diameter of our chassis jig. And there you can see there's our tube geometry. Once again, repeating the same thing for the other tube. All right, now that we have that geometry done, what we can do is make the actual connector, median, in between the two. So what we have to do first is, because SOLIDWORKS automatically hides the original sketches that you use for 3D features, you just have to go in and manually turn those back on. Now, what we have to do is create a 3D sketch to start off our geometry. So you'll notice here that I am going into my line tool and I'm going to select the 4 construction lines. This just means that we're going to be creating lines that won't be used in the final geometry. They're really just for references. And what I'm doing here is just making a quadrilateral that is connecting all of the points with each other. All right, great. Now we need to create another set of construction lines, this time going laterally instead of longitudinally. So these are going to be parallel to the tube axis lines. You can see here I'm sort of deliberately making these lines, I guess, asymmetrical. I really don't like to use SOLIDWORKS' automatic snapping tools. So usually I like to go back in and define them myself. A shortcut for this is holding down each of the lines, making sure that's blue, and doing this while holding the shift button. So there, and then you can then define how you want them to be related to each other. There, I said it was parallel, doing the same thing for the bottom now. And then after this, we need to define the dimension between these two lines. This is going to be another set of global variables. One of the things about global variables is that you can actually treat them sort of like normal variables in an equation. Here, I'm going to set this as half of the outer diameter minus 0.1 inches. You'll see why we want that 0.1 inch offset a little bit after, but just typing this in like a normal, how you would type this into any sort of calculator online. Use 0.5 asterisk, and then the global variable. Once again, we're just going to use OD at Chassis Jig, or ch26.chassisjig.assembly, and then minus 0.1. Now, once you've done that, you can go ahead and do the same thing to the bottom. After this, we need to define some more lines. So here I'm going to be just connecting these two lines that we've made for ourselves. You can notice that I'm using regular sketch geometry lines now. I'm not using construction lines anymore. And so here I'm positioning this median so that there's not really an overhang at all. This is sort of arbitrary, very loosey-goosey, no real hard and fast science. But yeah, just making sure that all of our contours are closed. That way we have that shaded box, so we'll actually be able to have a 3D geometry. But yeah. Here I'm defining these lines as parallel to the construction lines. On the right-hand side, you can see that it's not really feasible exactly to define it as parallel, but on the left-hand side, it's much more feasible. This is going to be a sort of judgment call on your guys' parts. make sure it looks decent. Having them parallel isn't obviously required, but it is going to be very good just for the neatness of everything. And so, depending on how your geometry between whichever tubes you do are, that's going to determine how you exactly define these. Great. And then next up is to make a mid plane in between these two. So we're going to use an extruded feature, and instead of using the default blind feature, we're going to do mid plane. Now, since we're using a 3D sketch to reference our extrude, we actually need to define a direction of extrusion. What I usually like to do is just use that sketch line that you saw I selected in the front bulkhead. That one, it's just a horizontal line that I usually default to. If it doesn't work, choose a different line. Again, no hard science here. Now this thickness does use another global variable. So this is just going to be T for thickness.
Actually wasn't recording for the past 15 minutes of me recording this, but hopefully my voiceover was good enough. We're at this point in the jig, so what we want to do now is do our sweep cuts through so our tube can actually like fit inside. So I'm still editing this. What I want to do now is instead of doing an extruded, we want to do a swept cut. And I can't actually click this because the recording thing is blocking it, but swept cut is just the top here. This framing is going to be a little bit weird for the time being, but just bear with me. Again, we're going to use a circular profile, and we want to click the original sketch lines that we had. So here, and once again, it's going to be another global variable, you can guess, ID, for inner diameter. Just like that. Once again, we're going to use a separate feature to do the other tube. Now, it turns green. It's pretty normal. I don't know why it does that. Boom. All right. Now that we have that, we can start making the little bolting flanges. So how we're going to do that is we're going to use what's called a reference geometry. Now I can go back into full screen. It's still under the features. If you look over here, reference geometry, we're going to make a reference plane. Our reference plane is going to be perpendicular to this median right here, and coincident to the tube axis. So our first reference, I'm just going to select this as perpendicular, and then our second reference is going to be, we'll go with this one for now. So I'll show you guys how to do one set of flanges, and then I'll just sort of speed run through the second set. All right, now that we're on a plane, we can do our sketch for that. So actually, I'm going to save this and open the part. This is just going to make it a little bit easier to actually move everything around and see it. All right, we're going to start a sketch on this plane that we created. It always starts upside down. I think it's something to do with like plane normals in SolidWorks, but anyways. We're going to go here, and I'm going to do something, well, first let's just do a construction line, basically duplicating this axis right here. You'll see why in a little bit. We're just going to use it as a mirror axis, but like I said before, whenever I want lines defined in a certain way, I like to make them purposefully asymmetrical so that they don't snap with anything in SolidWorks' snappy thing, just because I like to define them myself. So here I'm going to define these longitudinal lines as parallel to the tube axis, and then as you might guess, the other ones are going to be perpendicular to each other, just so that we get a nice rectangle going. All right, now that we have our lovely rectangle, we want to make these lateral lines coincident to these points. Now it's not actually going to be coincident, but it's going to define the width of our rectangle. All right, good. So next we want to drag this out so it's coincident with the edge, just like that. And then we're going to dimension this to be 1/2 inch. I don't actually have a global variable set up for this, so you can just type in a good old 0.5. All right, and now quickly I'm just going to make some construction lines, splitting this rectangle into quadrants. This is going to be easier for centering and positioning our holes, as you'll see right now. So just making a hole like this, arbitrary size, and I'm going to define it once again with a global variable. This is the clearance hole size for a 1032 hole that we found works. The global variable is just called hole. I'm very creative with my names. All right. And now what we want to do is mirror this over that shorter construction line that we just made. So like this, it's going to mirror using the mirror entities button right here if you didn't just see. And I'm going to define the distance between them to be 1 inch. I also don't have a global variable for this. I figured these ones were pretty standard enough that I won't need them. All right, but now the little weird thing, I'm going to select this line and make it into a construction line. And the reason why I want to do that is because I want to have a little offset right here so that once I extrude it, it won't make a weird divot inside in between the curved edge. So just like this here, the offset doesn't have to be anything like crazy. That looks about good. Again, pretty vibey. Now we want to mirror this entire thing across this original axis that we made for ourselves. So selecting this, selecting the two holes, and I want to mirror this across here, just like that. Perfect. You can go ahead and save this sketch. And now we're going to extrude it once again with a midplane. And instead of doing T, we want to do 2T. So 2 times T. You'll notice that even though we're outside of the assembly, because we made the part inside the assembly, the global variables still work, which is pretty neat. All right, so now that's done, I'm going to go ahead and speed run the other side. Okay, so now that I've finished both of the flanges, I'm now going to do what's called a split feature. So if you go into the top left and press Insert under Features, if you go down, there's going to be this little button with a split. And this is just going to be able to, if we select our planes, both of them, and we press Cut Part, then it does just that. It splits our part by cutting it. So we're going to have to check mark all the different resulting bodies that we want to keep. And now we have all the individual parts. So these are going to be the 3 bodies that are going to actually be printed, but the final step that we want to do is label these, just for the ease of manufacturing afterwards. So, let's see. Go in, where's, crap. Alright, if we go into the original chassis jig, then we can actually verify which tubes are going to which little arm guy. So we can see that the smaller one is going to be this one right here. So this one is going to be tube 33. So the smaller one is going to be linked to tube 33. Verifying the right orientation, this is what we're going to see from the outside of the chassis. So that matches up. That looks good. What we want to do is now make a sketch with text. So in the sketch, there's going to be that little outline of an A, and we can select the flat face that we've made for a median. And then in our text, in bold, let's type out our tube numbers. So the top one is going to be tube 12, so type out 0, 1, 2, and then 2 line spaces, tube 33, which should also be in bold. Now on top of this, instead of using the document font, which is a little bit small, we're actually going to uncheck that and use, instead of units, we're going to go into points, and we're going to do 0.36, 36-point font. This is just what I found to be a good size. So it actually didn't work. I'm going to do that again. To be honest, it's a little bit finicky, but pretty quick. So again, I'm going to select 36, and hopefully, there we go. Look at that. All right, and so now if you want to move it around, you can drag this little blue dot, and it'll move around for you. I think this is at like a fine spot, as long as it's pretty clear which tubes are which number. So now we can save that sketch. And then our last step, go into basic modeling tools, or sorry, features, and then right here, we're going to click the wrap. And instead of the first default selection, we actually want to go the one that's a little bit more sunken in. It's called a deboss. And it's automatically selected the sketch that we want. Now we just have to select the face there, and we'll do a deboss of 50 thou, so 0.05 inches. Click the green check mark, and there you go. It is successfully debossed. So we go ahead and save that, and go back into our original jig. There we go. Save everything. Make sure to save everything. And there you have it. The jig is up. The jig is complete.